The intersection between two planes defines a line. So we can use a Stereonet to figure out the trend and plunge of a line of intersection that's defined by two planes if you know their strikes and dips. So in this case, we have one plane that strikes 30 degrees and dips 60 degrees towards the southeast. The bulge of that great circle is towards the southeast side of the tracing paper, and it makes a great circle lining up with 60 degrees. The second line has a strike of 342 degrees and a dip of 70 degrees to the northeast. Again, there's a bulge towards the northeast side of the tracing paper. And if we spin the tracing paper so that that second great circle lines up with north, we can count from the outside of the circle, count how many great circles we've crossed until we see that the dip of that plane is 70 degrees. Then the intersection between two planes is the place where the two great circles cross. So we're just going to make a dot where those two great circles cross. And then we're going to figure out the trend and plunge of that line. We start by lining up that dot along the equator. And then to find the plunge, we're going to count along the equator from the outside of the circle until we get to that dot. And in this case, the plunge is 60 degrees. Then to find the trend of that line, you're going to make a tick mark on the equator line while the dot is still lined up along the equator. Then we're going to spin the tracing paper until north on the tracing paper lines up with north on the Stereonet template. And then we're going to count along the outside, the primitive circle, until we get to that tick mark and use that to figure out what the azimuth bearing of the trend is. In this case, it's 123 degrees.